Hello everyone, this is Dr. Asif from the Department of Geography, Jamia Millia Islamia, New Delhi. I am working here in the capacity of assistant professor. Dear students, today I will discuss with you a module entitled Integration of GIS, Remote Sensing and GPS. Dear students, as you know, with the development of GPS technology, it not only increases the ease and versatility of its spatial data acquisition, but has also diversified the approaches by which it is integrated with remote sensing and geographical information system. Dear students, our objective in this module is to analyze how the integration of these three disciplines is helpful in a better understanding of in the better management of the resources available throughout the world. Dear students, we will discuss how the integration is helpful in the management of our resource. So let's go with the discussion. Dear students, you all know that 21st century is known for its development. This century lead to the massive race of development. We are moving in the direction of development, but side by side we are facing many problems in modern world. Like we are facing the problem of climatic change, the temperature of the world is increasing, we are facing the problem of population increase. You know, the population of the world has increased manifold during the last few decades. This increased population put a lot of pressure on our natural resources. To manage our natural resources, geospatial technologies are one of the tools by which we can manage and we can analyze our natural resources. With the help of the geospatial technologies, we can collect the data, we can analyze the data, we can interpret the data, and it can be a problem solving. So dear students, the problem which I have discussed with you can be solved with the integration of GIS, remote sensing and GPS. Before going to discuss the integration of GIS, remote sensing and GPS, it is very easy, it is very necessary to understand these disciplines separately. We must have a little knowledge about these three different disciplines, because without having a knowledge of these three different disciplines, it is very difficult to understand the integration of remote sensing, GIS and GPS. So first of all, I would like to discuss with you remote sensing. I would like to tell you about the remote sensing. Remote sensing is nothing but it is a technique in which we get the data about an object or phenomena without being into direct physical contact with this phenomena or with this object. If we want to give the example of remote sensing, our eyes can be one of the best example of remote sensor, because we can look while sitting in a window, we can look outside, we can observe the phenomena outside. While sitting on the roof, we can observe the phenomena. Our eyes therefore able to observe the phenomena without being into direct contact with the phenomena. But our eyes are restricted mainly because we can feel only visible part of EMR. EMR is the electromagnetic spectrum. The second important restriction to our eyes is that we have to move along with our body to observe any phenomena. The third important restriction to our eyes is we cannot form a long lasting images in our mind. As you know, our memory is very short. So in short, we can say that remote sensing is a science which observe the phenomena, which observe the objects without being into the direct contact with it. I would like to explain how remote sensing function, how remote sensing work. With the help of a diagram, I would like to make you explain how it works. You know, we required source of energy for the remote sensing, and you all know that sun is the ultimate source of energy. From sun we derive the source of energy. This is the ultimate source of energy, and it passes through the atmosphere. It passes through the atmosphere and then interact with the object which we want to observe, about which we want to get the data. After interaction with this object, the object reflects the energy to the sensor which are mounted on suitable platforms like aircraft or satellites. So this data is traveled to the sensors which are mounted in an aircraft or in a satellite. After getting the data from the object, the satellites record the data. After recording data, it sends it to the ground control system, where we start processing the data. After the processing and analyzing the data, we use it into different applications. So this is the whole way through which the remote sensing works. So dear students, through this graph I explained you how remote sensing works, how remote sensing function. But to get a better understanding of the remote sensing, two important things which we need to understand is electromagnetic radiation and electromagnetic spectrum. First of all, I would like to tell you what is electromagnetic radiation. Electromagnetic radiation is the radiation which we get from the sun. It travels with the speed of the light in the form of short wave. EMR basically travel in the form of wave. And there are two important things which are related to waves. One is wavelength and the second is the wave frequency. I will draw the wavelength and wave frequency on this board so that you will be able to understand what is wavelength and wave frequency. Look at this. From this point to that point, that is the crest of the wave to the crest of the wave, it is known as one wavelength. Or from the throat of the wave to the throat of the wave, it is known as a wavelength. There is an inverse relationship in between wavelength and wave frequency. Wave frequency is the number of waves passing through a particular point of time, passing in a particular period of time. There is as I told you, there is an inverse relationship between wavelength and wave frequency. The second important thing which I would like to explain about remote sensing is electromagnetic spectrum. Electromagnetic spectrum is a scale on which we draw the different wavelengths and calculate these on which we draw the different wavelengths. Electromagnetic spectrum can be divided into different parts on the basis of wavelength and wave frequency. As I told you, there is inverse relationship in between wavelength and wave frequency. It can be divided into ultraviolet. Ultraviolet has the shortest wave frequency, shortest wavelength. Ultraviolet region is having shortest wavelength. Therefore, the wave frequency will be higher. The wavelength of ultraviolet region is 0.3 to 0.4 millimeter. The second important region is visible light. This is the light which we can observe through our eyes. This is the region in which we can observe different colors. The length of this region ranges from 0.4 to 0.7 micrometer. The third important part of electromagnetic spectrum is infrared region. The wavelength of this region is from 0.7 to 100 millimeter. Its width is more than 100 times than the visible region. The fourth important region is microwave region. The microwave region has the longest wavelength. Its wavelength varies from 1 millimeter to 1 meter. Remote sensing devices are designed in such a way they can detect the energy interaction in these different parts of the spectrum. Now I would like to discuss with you global positioning system, that is known as GPS. You know, GPS gives us a very precise location about a point, about object or any phenomena on the surface of Earth. It gives us three-dimensional image of anything which we want. Global positioning system is a recently developed technology which is very helpful, and we are using this technology in almost every sphere of life in modern era. Initially it was developed for the military purposes, but after 1980, US Departments of Defense allow for the civilian purpose of this technology. So we use the GPS signals to get the three-dimensional location in terms of three coordinates. These coordinates are x coordinates, that is for latitudes, y coordinates, that is for longitude, and z coordinates, that is for height. In terms of these three coordinates, we want to get the position on the surface of Earth. You know that if we are having a GPS receiver, we can get the signal from the GPS satellite and we can use it. If we are using two GPS receiver, that is known as DGPS or Differential Global Positioning System. This helps us in giving better accuracy. If we want to get a better accuracy of an object or a phenomena on the surface of Earth, then we use DGPS. Now I would like to explain the functioning of GPS with the help of an example. Suppose we want to measure the four corner of a building. This looks very simple. As you all know, will think that it is very simple to measure the four corner of a building with the help of the GPS receiver. But is it not as simple? Because to get the precise location, to get the correct location, we want the satellite in the sky which are evenly distributed. Moreover, we want to get the data, get the signals from at least 4 satellites to get the three-dimensional position. So the distribution of the satellite in the sky, and at least we should get the signals from the 4 satellites, that is very important. The distribution of the distribution of satellite in the sky is known as the dilution of precision. Dilution of precision is nothing but it is the mathematical calculation of the signals of the satellites which we receive on our receiver. It is about the geometry of the satellites. Geometry is nothing but it is the distribution of the satellites in the sky, how they are distributed. Dear students, now I will explain you the working concept of GPS. With the help of an example, I will make you understand how GPS work. Basically, when we switch on our receiver, the receiver is equipped with an antenna and inbuilt software. So while switching on our receiver, we will get the signal from the satellites immediately, and with the passage of the time, we will get the signals from few more satellites. After getting the signal, the inbuilt memory of the software which is in the receiver is being used to give the location of a particular place or an area. The third important concept is Geographical Information System or GIS. GIS is nothing but it is an analytical tool to analyze the spatial data. It gives the answers of many questions through the analysis, through the storage, and through the description of spatial data. It is helpful in solving many geographical problems, many environmental problems, and many problems which are related to the human being. We acquire the data through different sources and we process it in GIS environment and get the desired result. The GIS data can be classified into spatial data and attribute data. There are two important data modules of GIS. One is known as raster data module and the another is known as vector data module. I have explained you remote sensing, GIS and GPS. Now you will be able to understand the integration of these three disciplines. How the integration of these three disciplines is helpful in getting the information throughout the world and analyzing the information. Since we are discussing the integration of GIS, GPS and remote sensing, there are several modules by which we can explain the integration of remote sensing, GIS and GPS. The important method of integration are number 1 linear method, number 2 interactive model, number 3 hierarchical model and number 4 complex model. I will explain you all these models in detail with the help of few diagrams. So I will discuss linear model of integration.
It is clear from the figure 6 that data flow linearly from GPS to remote sensing and ultimately to a GIS in a linear model. In this model, unique strength of each component is utilized to the maximum. GPS is used to obtain geometric control for aerial photographs and satellite imagery. Rectified photographs and image are then integrated into a GIS database. The linear structure of the model implies that three components of the model are not equally important. A GIS, being the final destination of the integration, play a dominant role. Rectified images form the part of the GIS database. All the spatial analysis and modeling are being carried out in GIS. By comparison, the role of GPS is subordinate as it supplies point-based data to remote sensing. In the final GIS database, GPS derived data are not visible due to the absence of a direct connection between GPS and GIS. The second important model is interactive model. The interactive model bears a striking resemblance to the linear model in structure, as it is shown by the figure 7. In this model, data flow mutually between remote sensing and GPS and between remote sensing and GIS. The ultimate task of integration may be carried out in a raster GIS or in a digital image analysis system such as IRDIS Imagine. Thus, remote sensing can no longer be perceived as mere data provider to GIS. Although it is possible for the data to flow from GIS to remote sensing in this model, but the data flow from GPS to remote sensing and from remote sensing to GIS is much common, as the arrow's width in figure shows. Number third, hierarchical model. There are two-tier integration in the hierarchical model. The first tier of integration occurs between GPS data and remote sensing. The second tier of integration involves remotely sensed data, GIS data and mathematical models. The task of spatial modeling can be done in remote sensing or a GIS depending on the data format. This figure 8 shows the hierarchical model of integration between remote sensing, GIS and GPS. The fourth is the complex model of integration. Containing all possible association between any two components, the complex model represents the ultimate or total integration of remote sensing, GPS and GIS as shown in figure 9. Now I would like to explain the existing application of integration. The value of integration of remote sensing, GPS and GIS lies in those applications that requires georeference data instantly. These applications include resource management and environmental monitoring, emergency response and mobile mapping. I would like to explain you one more thing, that is prospects for integration. One of the existing prospects for the integration of GPS with remote sensing and GIS is the development of the LocationAware personal digital assistant. This system consists of a handheld computer that is equipped with GPS receiver. The information about roads and their geometry and other attributes is stored in GIS database. More innovation data like popular tourist attraction with their ground and aerial photographs as well as satellite imagery making their way to GIS database. Common applications of personal digital assistance, that is PAD, are vehicle navigation, route planning and tourism. Drivers can rely on the system to find their way out. Another example of PAD is the computer assisted self monitoring, in which PAD is used to capture vehicle based daily information. That is information about the start time, journey duration and vehicle position in terms of latitude and longitudes are collected automatically at frequent interval.
Dear students, we have gone through a detailed discussion about the integration of GIS, GPS and remote sensing. You all know that we have gone through a detailed discussion of individually of these three different disciplines. I discuss about the GIS, I discuss about the GPS and later on I discuss about the remote sensing. You know, we have discussed the various models through which we can integrate these three disciplines, and the application of the integration of these three disciplines has already been discussed. With the help of the above discussion, I may conclude that if we will apply these three disciplines individually, we will not be able to get the desired result. If we want to get the better result, if we want better application of these 3 disciplines, then we need the integration of these 3 disciplines. If we will continue with the individual discipline, it may be applicable in few applications, but it will not get the results in majority of the application. So the integration of remote sensing, GIS and GPS can be very much handy, can be very much helpful in maintaining the resources which are in a shortage on the surface of Earth. Thank you very much.